to remember. So that before the exam, you go to exactly what you need. You don't read stories now. No time to read big notes. Mass, constant everywhere. Your mass constant. Your weight varies from place to place. Number two, your mass is scalar quantity. And of course, your weight is vector. Very important. And number three, mass measure inertia. Whereas force, your weight measure force. Measure. So for the moment we are at the back, under mass here, measures inertia. Measures inertia. Then weight, measure force. Measures force. That's it. So you can see the difference between mass and weight. Mass is constant, weight vary from place to place. Your mass in Lagos will be your mass on the moon, unlike weight that vary from place to place. Now we have 7 fundamental quantities in physics. There are 7 fundamental quantities. And we have more than 1,000 derived units. So number 1, we have the mass, and our mass is in kilogram. We have number 2, length. Our length is in meter. We have number 3, you have time. Our time is in seconds. Number 4, we have currents. Our current is in amperes. We have 5, temperature. What we call temperature. Our temperature is in Kelvin. Kelvin. We have number 6, luminous intensity. Luminous intensity. And then you have candela, CD. Number 7, amount of substance. Amount of substance. That's mole. Mole. 7 of them. So if you are not among these 7, then you are not a fundamental quantity. That means you are a derived quantity. All the one in bracket are the fundamental unit. Kilogram, meter, seconds, ampere, Kelvin, candela, and moles. They are all fundamental. From there, we go to dimension. Dimension. Another dimension, we have what they call length. Length and its family. Length and its family. They are all L. So what are the family of length? Distance, displacement. These are the family of length. Displacement, height, radius, diameter, extension, width, what they call breadth, height, like that, all of them. They are all family of. So all of them here, dimension of distance, L, displacement, L, height, L, radius, L, all of them, L, L, L. And of course, mass. Mass na M. And number 3, time. Time na T. And number 4, current. Current na I. I. Now, when we refer to accuracy, there's relative darkness here. Anyway, if you can see, no problem. Accuracy. So please, the 2 lines cannot be off at the same time. The one here at the back of the door, please, somebody should help me there. The back of the door, either this one or this one of them. That one. Accuracy. half of smallest graduation. Is there no switch for this place? Half of smallest graduation. That's accuracy. And the smallest graduation is range. Better. Range over number of division. SG means smallest graduation. Graduation. Then in your maths, we are taught percentage error. And that's error of actual value times 100. That's all. So we are through with the topic 1. Yeah, that's all. What we are just done now in 10 minutes is what we did for 2 weeks. Yeah, we are through. So we'll take 10 questions that JAM can bring. Question 1, are you true? This is the only time I will be asking for, are you true? I just ask you that one just to encourage you. Are you true? Conche me. Revision class. Question 1. The dimension of impulse is. Question 1. The dimension of impulse is. Question 1. The dimension of impulse is. Impulse. Impulse is topic 3, so don't worry. We'll soon get there. Solution. So impulse is first times time. Is what, class? So we'll soon get there. I wanted to add one here for you. All of you under that dimension, please. 5. And that's force. And that one is always common. MLT minus 2. So put it. So force is MLT minus 2. That one is the commonest. So impulse is first times time. So I don't be deriving it every time. Dimension for force is what? ML. What's time? T. Answer will now be what? That's all. Minus 2 and plus 1. This is plus 1. Indices. So minus 2 plus 1 will be minus 1. Minus 2 plus 1 will be minus 1. Question 2. Question 2. Question 2. What is the value? What is the value measured by the vernier caliper shown below? What is the value measured by the vernier caliper shown below? What is the value measured by the vernier caliper shown below? What is the value measured by the vernier caliper shown below? This is 4. Don't draw what you think, draw what you see. Oh. Look at that. This one, they're on the same line. Some of the things you were taught in chemistry today, have you had them before in revision? You are reading their note. So it's just like revision. Terminal, non-terminal, phosphine, arsine, ammoniacal liquor. If you are drawing these two, they are on the same line, because some of you will not see it. This one. Because they're on the same line. Oh yeah, now let's get the value. This is 3. The one before 3 is what? 2.9. Because I'm going backward. So what are you trying to do? I'll go and look for where this is the main scale. This is the venial scale. You go and look for where the vein scale intercepted the main. Where the vein scale started. The vein scale is here now. Started from here. The venial scale. So this is the venial scale. So I have to record this value. This value from the main scale. Because this is the venial scale. So this is 3. The one before 3 is how much? 2.9. The one before 2.9 is how much? So we're going to record 2.8. You record the main scale that was there before the venial scale starts. So this is 3. This one 2.9. This one 2.8. You now go and look for where the main scale and the venial scale overlap. 0.01, 0.02, they're not on the same line. 0.03, 04, 05, 06, 07, they're on the same line. They're on the same line. So I'll now record 0.07. cm. So the answer will now be 2 point what? That's the answer. Look for where they're on the same line. Country. What? Pardon? Your screen is not showing. Okay, tell Daniel or Michael. That's their work. Daniel and Michael. What we call job specification. My own job is teach, instruct, encourage, motivate, conduct exam. Results must be out. My work is now screen connection. So one of you should go and tell Michael or Daniel to help you. They will. Let's go. Question 3. I'm not waiting. No. Question 3. Which of the following pair of quantities? Question 3. Which of the following pairs of quantities? Thank you. They said this screen. Michael, thank you. That's very prompt of you. God bless you. Which of the following pairs of quantities have the same dimension? Which of the following pairs of quantities have the same dimension? So the following pairs of quantities have the same dimension. Option A. Option A, tension and surface tension. Tension and surface tension. Option A, tension and surface tension. Option B, pressure. Pressure and power. Option C, stress and pressure. Option D, momentum and moments. Momentum and moments. Look at that. Is it working now, Michael? It's working. I'm sure they didn't say thank you to you. Don't mind them. Okay, will that one be ready today, the first one? When it's ready, let me know, please. Today. God bless you. Oh, yeah. Look up. If your name is a false, all of you have MLT minus 2. What do you have, class? Mr. Adam, can you give me an example of false? Yeah, weight. Weight is a false. Tension is a false. Upthrust is a false. Division between jotting. You won't have time to read all the voluminous notes again. Friction is a force. So all these one are forces. They all have that. But the word surface tension. Surface tension means what? Force per length. Forget about the 2L. Oh yeah, class, who can tell me what's the dimension for force? MLT minus 2. What of length? Pium. What do you have left? Are we the same thing? This one and tension. See tension here. We're not the same thing, Abi. Although we have tension inside us, but we're not the same. Class, remember your SS2. What is the formula for pressure? You are good. Force over area. Waiting be force. MLT minus 2. Area and call length times breadth. We have ML minus 1, T minus 2. Power. I've got the power. Power is what? Work done over. Work done over. Can we be the same thing? No. Work done over time. Power. I'm just trying to derive it in case they ask you to pick any of them. Another question. Power is work done over time. What is work done? Force times over time, Abby. What is force? ML. What is distance? What is time? That would now be L times L equal L squared T minus 3. Abby? Power and pressure, are we the same thing? Never. Claire, what is your stress? What is pressure? Are we the same thing? As I see. I will have used that one to just pick it, but I don't want to derive in case he asks tomorrow find the dimension of pressure. We have gotten it. Force over area. Find the dimension of power. Let's go. Number what now? What are the following about mass and weight are correct? Which of the following statements or which of the following about mass and weight are correct? Which of the following about mass and weight are correct? About mass and weight are correct. Option A. Option A. Sorry, remember, go one. Weight is the force of gravity on a body. Weight is the force of gravity on a body. Weight is the force of gravity on a body. Remember, go two. The mass of a body is the quantity of matter in the body. The mass of a body is the quantity of matter in the body. Remember, three. The mass of a body varies from one place to the other. Mass of your body vary from one place to another. Number 4. The mass of your body is greatest at the equator. The mass of your body is greatest at the equator. Is greater at the equator. Pick an answer. You can combine answers though. You can say 1 only, 2 only, 1 and 2, 2 and 3, 1 and 3, 2 and 3, 1, 2, 3 and 4, 1 and 4. I won't give you option. Pick one. What's number 1? Oh yeah, switch it off. Let me hear myself. What's number 1? Is that correct? Very correct. The measure of the force of gravity. What's number 2? Is that correct? Very good. What's number 3? Is that correct? What's number 4? Is that correct? No, because the mass of your body is what? Constant. Whether you are at the equator or pole or moon, the mass is the same, not greater at the equator. You know, like that. So the answer is 1 and 2. Question what now? 5. The velocity of your body, the velocity of the musical notes. The velocity of a musical note. The velocity of a musical note in a stretched string. Velocity of a musical note in a stretched string. In a stretched string. Velocity of a musical note in a stretched string is expressed as, in a stretched string, is expressed as V equals K T raised power X mu raised power Y. Is expressed as V equals K T raised power X mu raised power Y. V equals K T raised power X mu raised power Y. Where T is the tension. Where T is the tension. Where T is the tension. And mu is the mass per unit length. Where T is the tension and mu, that symbol is called mu. Where T is the tension and mu is the mass per unit length. Full stop. Find the value of X. Find the value of X. Amos, are you okay? Are you fine? We are not eating well. See bone everywhere. Sorry. You guys are really trying. I'm so emotional now. You see your bones. Sorry. You see me after the class. You too, you have bone. Sonia, you have bone. Eh? Bone cause scapula. Eh? You have bone. There's no bone in your own neck. See flesh everywhere. Oh yeah, find the value of what? X. Oh yeah, let's quickly solve. I want to find X. That's a very interesting question. Now our V, KTX, mean Y. Class, our V is the velocity, Abi. In our SS1, what formula for velocity? Whether you say distance or displacement, anyone. Displacement over time. Oh yeah, class, help me. Displacement is what? L. What of time? T. It can't go. What will it be? Put it here. So you don't have LT minus 1. Mr. K is constant. Leave it there. That T is what? Check. What is that? What is that T? Tension. Tension is a what? Force. What's the dimension for force? You put it here. Minus 2. Put it here. Power what now? X. What's that mu they give us? Mass per. Mass per. Mass per. What's mass? What is length? It can't go. What will it be? Very good. So you have ml minus 1. Power what now? Y. Let's go. Can you see? Serious question. LT minus 1. Leave the K. Open the bracket. M carry your own X. M power X. L carry your own. L power X. T carry your own. Minus 2X. M carry your own. M power Y. You carry your own. L minus Y. Oh yeah, now all the L you bring them together. Oh yeah, you now have K. Mr. M, do we have two M's there? There are two M. Bring them together. Indices. S plus. Go to Mr. L. What's L again? X minus. Mr. T. Now only one T there, be. T raised power what? We're looking for X. That's it. Equating T's. Equating T. Equating T. What are you having now? T raised power minus 1 equals what, class? That's called dimensional homogeneity. Say that, everybody. That means they are homogeneous. They're on the same side. T can cancel to pium. What do you have? Minus 1 equals what? S equals what? Minus 1 over what? So what's your X? That's it. That's all. That's all. If they say find Y, can I come and use the one for L? L power 1, this power 1, equals L power X minus Y. You now put the half. I'll go through it again because it's on a standard. I saw a paper now. Latifa has been sleeping since morning. If you are Latifa, somebody love you, he's reporting you to me. Wake. We can't be doing revision and still sleeping now. So that's it. So let me go through it again. Velocity is displacement over time. Displacement over time is velocity. Over time. What's our displacement? Don't forget the displacement. That's what? L. Time called T. You can't go up. LT minus 1. K will be here. Our T is tension. Tension. Mu, mass per unit length. Mass per unit length. Mass per unit length. It will go up minus 1. You now replace them. Tension, come and stay here. Mass per unit length, come and stay here. Open bracket. M raised power X. L power X. T minus 2X. Open bracket. M power Y. L minus Y. All the M's will come together. All the L's will come together. All the T stay alone. You now equate them. So why do you use T? Because I observed that T is only one that has only X. Others, you have S and Y. S and Y. That's why I use that one. So I can easily get my X. Next question. Number what? What are the following units? To the following units is equivalent to the watts. To the following units is equivalent to the watts. My Deborah there, I hope she's not sleeping. Deborah, don't sleep this week. Oh. All eyes are on you in that corner. About this one, catch up at me forward back, bang, bang. No sleep. So the following unit is equivalent to the watts. Option A, kilogram meter per second squared. Write the option. No? Option B, kilogram meter squared per second squared. Option C, kilogram meter cube per second squared. Option D, kilogram meter squared per second cube. Look at that. First, are you fine now? Okay. Some of the students I went to, are they coming back now? Okay, praise God. Some has come. God answers prayer. Pray for them yesterday. Look at that. Want to find. Now, pressure is not always in this form. So they want to tempt whether you can get it. So I will say pressure. Claire, let's go again. What's the formula for pressure? What is force again? MLT minus. Area is length times breadth. Is it power they give us? Oh, sorry. Oh, shit. I didn't say shit. I said shit. Yeah. Power is, oh, sorry. What is for power? Oh, I beg. What is power? What is power? So power is what? You can remind us. Power is force times. That's work done over time. That's power. Work done over time. And work done is what? Force times distance. Over. What's force? MLT minus 2. What's distance? What's time? What is L times L? T minus 2 over T. What would that give us? ML squared T minus 3. Class, mass is M, Abi. What's unit of mass? L is length, Abi. What's unit of length? T is time. What's unit of time? So what's the answer there? Option D. That means you will dance when your result comes out. You don't need to know how to dance before you dance. There's some dancing. You just be dancing anyhow, Sha. You know, anyhow. I've done one now, so classwork. So when are we having CBT mock result? Today, sorry. Yeah, we are today. But before mass class, I think you should have it. Today. Me too, I'm unsure because I want to see your score. I don't have power one on one. The one you pass, amen? Amen. Let's go. Next question. Classwork. The derived unit of pressure can be expressed as option A, kilogram meter per second squared. Kilogram meter per second squared. Option D, kilogram per meter per second squared. Option C, kilogram meter squared per second squared. Option D, kilogram per meter second squared. Classwork. Okay, A and D are together. Let me check it again. Kilogram. This one is second squared. Thank you. Pressure. Clap. Pressure is force over. Force is what? Area anchor. L cancel. When this L go, what will it be? -1. And then what? Who can remind me? What's the unit of mass? Unit of length? Unit of time? Option what now? So you need to start believing in yourself. You can do it. Amen. Amen. Question number what now? 3 more and we're through. Which of the following instruments Mr. Adams, Michelle from top floor, has a phone with her in the hostel. She brought it to the class today now and she's busy pressing. Who is Michelle? Eh? Where's Michelle? Stand up. I'm waiting. Oh. Let me have your phone. Quickly. Bring it. Bring your phone. Fast. Yes. Quiet. Quiet. Hey, I don't want to hear noise. The fellow that sent that note to me, the Lord will bless you very well. You will score above 340. The fellow that did that, quiet, I'm talking to. The fellow that did that, love Michelle. All of you that didn't want to talk about it, you are just part of the partaker of, you want her to fail. And God is going to judge you for all those things. Somebody is doing something bad and you kept quiet. I said, I didn't want to talk. Oh, you're right. Which of the following instruments is the best for measuring diameter of a thin Constantan wire? Which of the following instrument is the best for measuring diameter of a thin? Let me have the phone. Just pass it. Go and kneel down in front of my office. Your class has ended. I'm sending you home today. Yeah. Pass it to me. Me, I'll be forcing myself to teach. The thing is even very hot. I'll be forcing myself to teach all of you. I'll do all the best. I'll fast and pray for you. Yet in the class, revision, topic 1. Topic 1 to start all over again. You are not writing. The fellow that sent that paper to me, the Lord will bless you specially. Amen. Don't mind what people are saying. You are a bad girl. Yeah. See, you are quiet. In God's calendar, listen to me. In God's calendar, God is going to favor a girl like that because she doesn't want Michelle to fail. But all of it that know and you kept quiet, you saw her there, you are not talking. God is going to judge you. Yes. You are your brother's keeper. So you kept quiet. I don't care. Because some of you be condemning the person. Why? Why must you do that? Hey, don't listen to them. Oh. Quiet. There are many of you that know many things that are bad going on in the hostel. You not talk. You know, quiet. I'm talking. Those who are talking now, they will score less than 150 in the exam. And so don't talk again. Because I know if I don't say that, you will keep on talking. You disrespect me. You know people are doing bad things in the hostel. Somebody don't pay lesson fee and he told you, and you are not talking. I say, I don't mind. Somebody stole things and you see it, and then it's not my business. It's your business. It can affect you. It can. One man in the Bible, he went to steal Babylonian garments. His name is Achan. When judgment came, do you know how many people died? Because of one man. Many people. All the children of that man died. And some of them are not. They died, all of them. And all the people around. Do you know how many people died because of one man's? I know. Somebody is doing something bad. Somebody is smoking. You know. Somebody is drinking. You know. Somebody is using drugs. You know. Someone doesn't come to class. You know. So I don't want to talk. I'm not talk. I don't want trouble. But God is going to punish you for that. Yes. But I'm sure all of you now, you are condemning the student that wrote down and say, why? But God, the heaven is clapping for her. One quiet, one man. God's judgment was on the land in a place. Judgment of God. Quiet, I'm talking. So people are talking, and I said it was less than 150. And they are still talking. What's my business with that? Judgment was going on. God was not happy with some people in the Bible. Then in the midst of that problem that God was not happy, one man, he went to bring a girl into the camp, was fornicating with the girl, having sex with the girl. And then one said, what? God was angry with us and you are still doing this. He brought a javelin. He thrust the javelin into the man and he entered the man and the woman. They died. This man, have you committed murder? No. Heaven was clapping for him. Yes. Because God was not happy with some people and then you kept on doing, you now want to add abomination. Heaven was clapping for him. It was recorded for him as a great man. So when it's something bad and you keep quiet, Mr. Dan said we should not use phone, but some people are using it, but I won't talk. Oh. God is looking at you now. That's punishment for you. I didn't want to be a backbiter. That's not backbiting. That's doing what God wants you to do. You are a watchman over people. The following instrument is the best for measuring the diameter of a thin constantan wire. Option A, calipers. Calipers. Option B, meter rule. Option A, caliper. Option B, meter rule. Option C, micrometer screw gauge. Micrometer screw gauge. Option D, vernier calipers. Vernier caliper. Pick one. And if everyone that wrote down to me, don't listen to any guilt from Satan. Say you have done, no, you didn't do anything bad. For heaven rejoice because you want somebody to do well. That is the meaning. If I say talking, keep on talking. You score less than 150. What's my business? Talk. Class, what's the answer? Micrometer, anything thin wire, thin paper, thickness. That's the answer. Number what now? Number 9. What are the following properties of a steel bar? What are the following properties of a steel bar? What are the following properties of a steel bar? Steel, S-T-E-E-L, of a steel bar can be measured. What are the following properties of a steel bar? Can be measured in terms of the dimension of length only. What are the following properties of a steel bar can be measured in terms of dimension of length only. In terms of the dimension of length only. Option A, weights. Option A, weight. Option B, density. Density. Option C, pressure. Pressure. Option D, volume. Yeah, pick one in your notes. Are we true? What's option A? Option B? Option C? Option D? What's your answer? The option, what is that? You are going to dance again. So why is it volume? Look at volume. What is volume? Somebody. Length times breadth. What is length? What is breadth? What is height? What's the answer? That's it. In terms of length only. Now only L gets. See your weight. MLT minus 2. Now, no, it has some other things. What's option B? Is it pressure? Density is mass over volume. This is density, mass over volume. Mass now weighting, M. Volume is L minus 3. Abi? If it goes up. Another one, ML minus 1, T minus 2. Pressure. Last question on this. Number 10. Which of the following set of quantity? Which of the following set of quantity is fundamental? Which of the following set of quantity is fundamental? Which of the following set of quantity is fundamental? Option A, speed, mass, and distance. Option A, speed, mass, and distance. Speed, mass, and distance. Option B, velocity, mass, and temperature. Velocity, mass, and temperature. Velocity, mass, and temperature. Option C, temperature, current, and length. Temperature, current, and length. Aisha, temperature, current, and length. Are you okay? It's wrong there. Option D, mass, acceleration, and time. Mass, acceleration, and time. Class, what's the answer? Very good. How many have you done now? Science and delivered. That's the end of topic 1. Topic 2. Scalars and vector. And that's where they go. Now 39 topics they go. 390 examples, 39 topics. Scalars and vector. Scalar. Please help me look for more students that are using phone in class. Help me, Joe. So that I will not work alone. Yes, I will not be working in vain. Joe. Those who are not writing, those who are wasting their parents' money. Vector. Magnitude and direction. Three P's of scalar. Power, pressure. And some people are still talking there. You know, some people are fighting for that girl now because they are just, let me not use the word useless. They are just the same type. Fighting for her. And so if Adam wants us to pass and she doesn't want to pass, what's the problem? They are fighting, they are supporting her. Some people are still talking at the back there. I can hear their voice. They don't care failing. Continue. I'm not going to stop you. 3 P's of scalar. Power, pressure, potential. 3 M's of vector. These are the way of remembering. Moments. momentum. Then we have magnetic field or flux. Then number 3, web is scalar. Web is scalar. Mr. Dan, what is web? Work, energy, and that's the topic. Work, energy, and power. Web is scalar. Work, energy, and power is scalar. Then another one, all fundamental quantities are scalar. All fundamental quantities are scalar. Do you know the 7 fundamental quantities now? All of them are scalar. Number 9, all forces are vector. Do you know the example of forces now? Is tension a force? What of upthrust? Once you are a force, you are a vector. And then there are some cousins. One are scalar, one are vector. Cousins. If mass is a scalar, who is a cousin? Weight. Only vector call. If temperature is scalar, who is the cousin? Temperature gradient. Temperature gradient. Temperature gradient. If distance na scalar, who is the vector? Displacement. So you don't go back and start reading big notes. No. It's capsular, synoptic. AOC, area of concentration. If speed is scalar, who is the vector, brother? Velocity. So if you can memorize some of these things, there's no question on scalar and vector example you cannot get. There was one that we find difficult to classify. That's called acceleration. And Mr. Acceleration is a word, vector. See, all these things on the board that I've just written now, you can use them to answer about 27 questions in your physics pack. All these small things. So the following is a vector. You just look at it. You are one of the 3 M's. I beg, momentum, that's the answer. So the following is scalar. Then you saw energy there. Now energy, because web is scalar. What the following is a scalar. All these things. So please, these are enough. Mr. How will I know scalar? How will I know vector? I've given you. This is how you can know. Then we have what we call component vector. Mr. Adams, can you still be discouraged now that exam is there? Never. I have a new vibe now. I can't be stopped anymore. So will I be playing? I'll just continue with those who want to go to school. I know I have a lot of people that love me in this class. So all of you that are playing, I don't even send you anymore. So look at that. Fx, cos, Fy, sine. Class, at what angle do we have maximum resultant? 0. Thank you, dear. Maximum resultant, theta na 0. What of minimum resultant? 180. Minimum resultant. Theta na 180. At right angle. At right angle. Our what? Our resultant now square root of what? F1 square plus what? F2 square. Topic 2 is, that's over. Yes, that's all you need. That's all you need. So we'll take 10 examples. We cannot finish the 10 before Jawski coming. The 5 will do. Continue. Wednesday is mock, so we won't have extra class on Tuesday. So I can go and rest, read. Not that you'll finish late and then you cannot read. But we may have extra class in the morning before economics class. This one wants to swallow me. Oh God. What's her name? Onu. Wonola. See me with Amos after class. It will like be opening eye. It will like open all your intestine like this. I know they see you. But that one is a reflex action. For you now, you want to start forcing it. Including Zena that is fasting, is trying to yawn now. So we are finished with topic 2. Let's go. Question 1. Question 1. Find the sum of the resolved forces. Find the sum of the resolved forces. Find the sum of the resolved forces along the x-axis. Find the sum of the resolved forces along the x-axis. Find the sum of the resolved forces along the x-axis. Is 10 Newton. 30 degree. 30 degree. 6 √3. 8 Newton. Yeah, draw. So I don't want to say anything like this in their life. Anything lying, anything on the salo. Okay. Now look at that. I want to find some of the resolved forces along the x-axis. Now, x-axis is always what? Cos. See it there. Now, because we have 3 forces now. Can label them. 1, 2, 3. It's along the x-axis. I will say summation fx. Now, because they said x-axis only, so it will now be f1 cos theta 1 plus what? f2 cos theta 2 plus what? f3. There are 3. So why cos? Because they said along the x-axis. 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 So let's go now. What's your f1? 10. Now, this guy is along the x-axis. Along where? That means the angle will be 0. 0. There is no angle. This one is making. It's in phase with the x-axis. So that will be cos 0. Plus the next guy. What's the next guy? 6 √3. And it make what angle with the horizontal? Cos 30. What's the next force? 8. How much angle does that one make with the horizontal? 60. Don't say 30. From here to the x-axis now 60. 30 plus 30. 60. 8 cos 60. Look at that. This one 10 cos 0. This one 6 √3 cos 30. Did you see the 30? Then the next one 8 cos 30 plus 30 is 60. This is not the time to keep quiet or be writing note that you don't understand. Ask neighbor, how did they get that 60? Ask now, because you may not have time to read all of them. So get it maximally in class. Somebody should help me. What's cos 0? What is cos 30? √3/2. What's cos 60? 1/2. 2 here, 1, 2 here. 10 times 1 is what? What is √3 times √3? 3 times 3. What is 2 in 8? 10 plus 9 plus 4. 19 plus 4, 23 Newton. Put on 2. Holy walk. Holy walk. 4, 1, 10. 9, 10. Holy walk. Jessica, you breathe middle floor. I was not eating for 2 days. And now dry fasting now. Waiting concern me. Holy walk. Okay, 23 Newton. Right, next question. Yeah, I'm happy some people are already saying something that they know about things. So they are not going to be affected in any way. That's what you have to do. You don't say, I don't care. Those is not a lie. A ship moving northward. A ship moving northward. A ship moving northward. With speed Vx. With speed Vx. With speed Vx. Is acted upon by wind. Is acted upon by wind. Is acted upon by wind. Blowing due west. Acted upon by wind. Blowing due west. Blowing due west. Blowing due west. Blowing due west. Full stop. Draw a diagram representing the velocity. Draw a diagram representing. Draw a diagram representing the velocity VR of the wind. Velocity VR of the wind. Velocity VR of the wind. Relative to the ship. Velocity VR of the wind relative to the ship. SHIP. Look at that. Now we have a diagram like this. Look at the board. Read the question. Let me hear you. Northward. Oh yeah. This is northward. With speed what? VS. With VS, yeah. Yes, go on. Class. In your something. This is not Abby. Yes. What's here? Yes. What's here? Yes. So where is the ship blowing now? Ship is blowing due west. So because it's blowing due west, that means I have to draw it this way. Abby, this is west. This east. You know, so if it is a drawing due west, you can draw it like this. VW. And someone in my class is talking something else there, distracting us. I'm sure that's a why. What did I say we should find? I want to see the best diagram there. They give us 4. I don't want to draw this one. Give us 4. Let me put this VS here. I will explain. I don't want to give all the 4 diagrams. They give us. Let's draw it this way. This will be better. West. Or should I even draw the 4? Please make I draw the 4. What they say we should find, Seth? What they say we should draw? Which one will relative to which one? Relative to the sheep. Okay. Let me draw it this way. Sorry. Just use your hand. Yes. And when you are Benko, I don't want to draw the 4 for you. This is sheep. Now look up. I'm trying to go up like this. What we call rowing. There's a sport like that in Olympics. Rowing like a canoe. Paddling. As we're going like this, they intentionally allow the current, the water current, to be flowing this way. Shh, 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 shh. Like if you are going like this, and something is flowing this way, will you still end up getting to this direction? Will you be pushed to the right or to the left? To this side, to this side, to this side. This left, Abby. You will push it like this. Because something is going this way. And you are trying to go up, so you push like this. So instead of to reach here, the thing will just go like that. So this is the relative one you are looking for. This is wind. Is it wind? Is it fear they gave you? So draw. This is the resultant. Draw it now. I don't want to draw the 4 to waste our time. I will re-explain again. Let me give you that question again. We didn't give it right. A ship moving northward with speed Vs, settled upon by wind, blowing due west at a speed VW. Did I give you VW? VW, not V. The first one is VS. The second one is VW for wind. So this is wind. VW, the one for wind. This is ship S. This is wind. And then this is a VR, resultant. So for knots, you go up like this. This is knot. Wind is blowing due west, pushing it like this. Some people will not go this way. I have 4 option diagram. I don't want to draw. No time. I have some allegations here which I will investigate. So I think the prof is coming. So let me just disappear. If you have not seen your exam number, online students and physical students, please go to the admin, complain.